Hey everyone, morning. I'd just like to say that I finished these slides at about 3 p.m. yesterday and the demo, so bear with me. So I'm Michael Cade, I'm a field CTO at Veeam Software. Veeam have noticeably been around the industry protecting virtual machines in vSphere. We do a lot in Kubernetes and cloud native as well, and we've expanded what that looks like. I also, before I forget, I have to give a massive shout out to Dom and to Tim, who massively helped with some of the strange things that were happening in my cluster to stop things from working. But yeah, really, the premise of the session is to talk about disk, seeing a massive uptake in people using stateful workloads within Kubernetes from a containerization perspective, but also the insurgence of virtualization, VMs running on top. So we're going to get into like that foundation of disks, then what do we run on that? What are some of the operators and the databases and the data services that we see? And then obviously where there's data, there's probably important data. We should probably think about protecting that. As boring as backup is, it's also that insurance policy when bad things happen. So the state of the union. Where are we from a storage perspective within Kubernetes? Kubernetes has obviously been around for 10 plus years, and it's no longer just for your stateless applications, scaling up, scale down your web front ends, your stateless workloads. We've now got a pretty robust platform that enables us to run databases and data services within your cluster. However, I still see a lot of customers using external database servers or systems outside of the cluster, and now you've got an application that's spanning outside and it gets a little bit messy. And the biggest ask that I see in the field is, I need that, I want to bring it all under one platform, under one roof. I think a big part of that is the insurgence of operators. I'll touch on that and some of the trends around what we're seeing from an operator point of view. Just a show of hands, how many people are running stateful workloads in their Kubernetes clusters? Oh wow, you're already way ahead of it, like already doing it, and that's testament, right? If I asked that question in London last year or KubeCon over the last years, that number was 10, 20, 30% of the room versus the 60, 70% that we just saw. And I think that bottom trend, it wouldn't be a session in 2025 if we didn't talk about AI, but like realistically, Kubernetes for AI workloads or more so machine learning is obviously a data intensive workload in itself. So we're seeing a lot more stateful workloads land on Kubernetes because of that. So the evolution is happening if it's not already here, and then the enhancements around that I'll get into, things like the CSI and some of the fundamentals. So if we go back, like we started off in 2019 with the operator model, and operators obviously do a lot more than just databases and data services, but interesting enough, if we look at database operators, we started off with 7, and now we're up to 50 plus. There's some names on there that you'll absolutely have heard of, know of, that have created an operator, that lifecycle management of being able to do that. And that growth is just continuing. So foundations, what do we want to talk about today? Disks. Disks are where we start. Now, if a lot of you are developers and not from the operations side, maybe you start to consume data and it's just magic underneath that. But ultimately, disks and storage start somewhere. We either can take advantage of some local disks on our cluster. Spoiler alert, that's what we're going to talk about today. But equally, we can bring some shared storage into our cluster from a NetApp, from a Dell or something else, the same for SAN-based. Equally, if we're running these data services, and if I say data services, databases, ultimately I'm referring to some of the workloads around databases, message queues, logs, things that need to stick around when pods are going up and down and moving and all of that good stuff. They're probably important. So when I say about DR, I mean things like backup. I mean things like disaster recovery. What happens when bad things happen to our data? I was going to show this, but I think with the show of hands, we probably don't need to. If we don't have persistent volumes in our in our environment, then what happens to that Postgres pod that we spin up? We get Postgres, we start writing data to our database, but ultimately, if there's no persistence, when we kill that pod, bad things happen. We lose all of that data. That's what that was simulating. Again, I'm probably preaching to the choir a little bit here as well in that, like, what are some of the Kubernetes storage fundamentals? But for those few in the room that are new to Kubernetes storage, I just want to quickly touch on some of those foundational layers that we have within Kubernetes. And the first one is persistent volume. So persistent volume is what we get from the disk, right? It's really about what's dynamically created. It's where our data is going to live for that data service. So a Postgres database would live on that persistent volume. However, Postgres would then ask for a bit of that storage via a persistent volume claim. And so we have a persistent volume, which is the storage. Then we have a persistent volume claim. That's the application asking for that storage. And then we choose what tier of storage that needs to look like. Is that gold, silver, bronze for what it's worth? And in some clusters, we see some of that shared storage. Maybe that's an enterprise storage solution, like a NetApp, like a blah, 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 whatever. But equally, we might have some storage on our cluster spread across using something like Rook or Ceph Rook, Ceph, or Longhorn. But ultimately, we've got a choice, and you might tier that up in the gold, silver, bronze, simple terms. But this is about what capabilities, maybe it's how fast that storage is how we split up that storage. And what's made this massively important for us over the last few years is something called the container storage interface. And there's a whole history of storage on Kubernetes before that with in-tree and weird and wonderful things. The CSI just made things more simpler, for want of a better phrase from Brian earlier about complexity. Storage was complex in Kubernetes 5+ years ago. The CSI now kind of makes this a universal framework to be able to deliver storage from local NAS, SAN, cloud-based storage into our Kubernetes cluster. And the way I explain this in a more broader or a longer-term session, format session would be, this is like the universal travel adapter that we all have if you've traveled in, or the European travel adapter. Is if you think about the device that you've brought from home plugs into your universal travel adapter, and then that gives you power into that local environment. I had to change my UK plugs to get into European or the 2-pin. And that's really what that CSI does. It allows an enterprise storage solution to be able to plug in to a platform, a platform to provide that storage. Loads of boxes on here, and there's a lot of more features around CSI, but ultimately it's about being able to provision that data, that storage, to be able to consume it in your platform. There's other things like volume snapshots. There's things like dynamically expanding that. There's loads going on, and if you're interested, then there's obviously a weekly call about the storage SIG from a Kubernetes point of view. Which then leads me on to, so what have Talos done? And there was talk of this from a 1.11 perspective, and how do we stop Talos taking up all of that massive disk that we put inside of our nodes? And some of the fundamentals there was being able to actually, Talos only needs 10 gig, if that, right? So I don't want to do that on a 250 gig, really fast, expensive drive, especially on the edge where maybe a device only has the ability to have one disk. I just want Talos to have that little bit, and then I want to use the rest of that partition for something else. Maybe it is like a Rook Ceph type situation. Which then leads us on to the two key areas, and one that I'm going to touch on and go into a bit more demo and building out a simulated cluster is the raw volume. So the ability to enable us to use that unallocated storage for Rook Ceph. Equally though, we could bring existing volumes. If you've got a formatted volume that has data on that, you could bring that into your cluster environment and then start consuming that from a pod perspective. The issue with, and that could be existing rook-ceph drives, it could be just database raw files, it could be an XFS formatted disk, for example, and you could just use that with that pod that is only on that one node. Obviously, we're talking about multi-node as well as single node environments as well. So they're the key two areas, and they enhanced a lot of the stuff around user volumes as well, being able to encrypt and do all of that good stuff as well. But some of the benefits here is that, as I've touched on, there's no need to use that fully dedicated drive that was potentially expensive, massive capacity. Let's use that for more. And again, a big use case there would be on the edge, or also home lab environments where you're using mini PCs with only one disk that can go into it. I don't want to use that whole disk for the operating system, and the very small operating system at that. The other part is, and I'll show this in the demo, is being able to create these partitions as config patches or cluster patches, machine config patches, to be able to determine what that partition looks like on the system. So we can determine what that looks like. We can say, right, Talos, I only want you to have 20 gig, then the rest of it is free. Then later on, if you wanted to add more partitions, you can do that through cluster patching within Talos. I've mentioned around you can attach that disk already that contains some sort of data, or even if it contains rook-ceph, Longhorn, bring that into your cluster. And yeah, it's not going to format anything as you bring that. It only mounts them. So my selfish use case, and that's not my home lab. My home lab has grown to 10 of these little mini PCs, as we do as technologists. But we could also simulate this in that edge use case, right? We've got 3 nodes. They're very small form factor. They have one drive. Only room for one disk. I don't have any shared storage to be able to use for this, but I need to run some stateful workloads. I need to run some mission critical databases that you're going to see on a demo as well shortly. Okay, there's a lot of slides here, so I want to get into the demo. So I'm using Omni to create this. You can obviously do this with Talos as well. Hopefully this is playing. Doesn't look like it. Let's click it again and see what happens. Ah, cool. So I'm in Omni here. I'm creating a cluster called Talos vSphere. I'm simulating those 3 physical nodes as virtual machines. If you're doing that, don't use VMXNet. Use E1000. There's a bug in that with Flannel. So here's that config patch that basically says, Talos, I only want you to use 20 gig of that disk that I have in that 250 gig drive. You can see that I've got 3 machines. I'm going to use the latest, although I saw 11.3 pop up yesterday, so you could use that. They're all going to be control planes and schedulable, if you saw that in there. I don't know what I'm doing here. This was yesterday during the Portainer workshop, so maybe I was listening to something else. Yep, you can all be that. And let's go and create that, and then we'll sit here for a couple of minutes. No, we won't have to. We'll speed through that, and you can see that we're only consuming that small amount of disk footprint across those 250 gig drives on each of the nodes. And if I then run a Talos a volume scan, you'll see, spoiler, that we're going to see a volume status, and we're going to see that one, the ephemeral volume status for our operating system, using 22 gig on each of the nodes. I'm only showing you one node, but you get the idea is that each one is only using 22 gig. Great stuff, great work, Cedero, for getting that in. What else do I show? I can't remember this. Oh, let's create the partition that we're going to then use for rook-ceph. So you see here the raw volume config. We're going to go and create a new config patch called storage. I think I remember doing it. You see this was created at 11:41 p.m. So yeah, we're going to add that in. Raw volume config, I'm going to take 100 gig more of that 250 as a partition. And you'll see by the time I get back, it's probably already reconfigured. If I then go and run that scan against that node again, we should be all good. And we'll have a new partition down the bottom called Talos con data, good stuff, on dev SDA6, which is important because I'm going to use that in my rook-ceph configuration in the next video. This is me spoiling my own demo. I'm not using those physical nodes because I'm running some mission critical data on them. So you can see, yeah, I've got that. This was the call out. This was what caused me to have to do it at 3 o'clock in the morning 2 days ago, is VMXNet. Don't use VMXNet, use E1000. If you use the VMware.sh script, it's going to deploy it with VMXNet. Then if you just use the default flannel CNI, things aren't happy, it doesn't work. Spoiler, rook-ceph will not work. E1000, I don't know why, I haven't had time to dive into it. Okay, so now we want to use that partition for something, right? We want to start putting some data in it, but we're not finished, so we have to deploy rook-ceph. So what does that look like? Hopefully that clicks, yeah, good stuff. What time are we here? Well, we've gone midnight now. Okay, just make sure I'm still awake. Yeah, I've got 3 nodes. Good stuff, right. Then we're going to add the Helm repo, probably do some update on that, make sure that it's all good. And then we're going to go and deploy the operator for rook-ceph to begin with. Again, we don't have to sit through this. We're also going to name that, label that namespace from a security point of view so that we're allowed to do some stuff in there. And then let's install the operator. So at this point, it's just the operator. It's just going to look after the lifecycle management of rook-ceph. That's it. We need to still then go and create we still need to create a Ceph cluster to consume that partition. So again, if you've got different tiers of storage, you might have multiple Ceph clusters that can hold and handle that. Just confirm, because it's getting late, SDA6, right, okay. So we're going to make sure that when we configure that, we don't use SDA5 and completely ruin everything. I don't know, maybe I experienced that. Now I can't remember where my values are for that cluster. You see before, I've edited, the power of editing. But ultimately, I'm going to go through this. This is my YAML manifest to create my, make sure that that's 6. Good stuff, well done me. And then let's apply that and quickly speed through. And this process to apply said Ceph cluster takes a bit of time. So we can see what that looks like, and I'm going to use the magic of editing here because we haven't got time to sit through everything. But yeah, if you sit and watch this, I've probably sat through watching this with the flannel and the VMXNet issues, and I've probably deployed about 15 clusters over the last 3 days, so I know this process very well. Editing I should have quickened this up as well. Ultimately, I think it took about 15 minutes to complete successfully. Yeah, there's a command to get all the logs, obviously from a Ceph cluster, from an operator point of view. I've been watching this painstakingly as well, and we get everything is up and running, pulling down images, good stuff. Right, let's speed this up. So what happens with Ceph is it goes and deploys these OSDs to each of your nodes. I believe they're daemon sets, and then once they're up, they consume that SDA6 as the partition, and that's where we start to expose that storage. I don't have my laptop here to be able to speed through this. This is sped up though. We don't have to sit here for 20 minutes waiting. Cluster created successfully. That's a good sign. That's good news. Do I show anything else? That looks finished. And then I go through and add the additional storage. So within my environment, you need a storage class. You need I need the CSI snapshotter. I need all of that good stuff to that. I think this is only very short, so I'm going to do that while we're talking on that. And basically, what all of these manifests do is go and create all of that extra CSI capability that I want to bring to my cluster. So you'll see snapshot controller, volume snapshot controller, loads of CRDs around the CSI to handle protection of that. Storage class as well, so that gold, I only have one storage class. Okay, so my mission critical environment, and I'm just conscious of time here. I didn't create this, I'm not that smart. I stole this from the open source community. I borrowed it for a demo, but basically it's Pacman, a Node.js application running with MongoDB stateful set that holds our mission critical data, our high scores, and all of the Kubernetes objects, resources that are consumed within that. Okay, so let's log a couple of important things. So let's just show you what that looks like. So Michael Pacman, yeah, tell me the 2 pods that I have. Great stuff, they're running. So a Node.js front end with a MongoDB backend. I've got a PVC, which is holding our critical data that is on our rook-ceph block. Type clear correctly, and then port forward that, and then we can log a higher score into our environment. Nostalgia is real. I could have sat playing this for a lot longer. What time? Oh, this is yesterday during the workshop. Yeah, so get some high scores, TalosCon, proof that I was here. And we have 2 high scores. Mission critical, you see, I just pipped the post with my testing one, great stuff. And so when bad things happen to good data, this is why we need to start thinking about how do we protect that. And this could be a virtual machine, right? Virtual machines are based on PVCs, and all of the Kubernetes resources around it. It's great for stateless workloads to just use your source code repository, GitOps type pipeline. You can just replay that, and your application is magically back. That MongoDB database, or the contents of that database, isn't in GitHub. It isn't in your source code repository. So we wouldn't be able to just get those mission critical data scores back. So when I think about disaster recovery, business continuity, making sure that that's available to all of my home lab users. My son, he likes Pacman. So I need it to be available all the time, and he doesn't want to have to, he doesn't want to lose his high scores. The power doesn't need to go off to the arcade machine. So we need to make it available at all costs, regardless of what the situation is, right? From a backup point of view, backup's been around for forever. It isn't just a new phenomenon within Kubernetes, but what level of protection is enough? And when we get into Kubernetes, the complexity of how do we back this stuff up is complex in itself. Not to mention the storage that we've just gone through and everything else within Kubernetes and our applications. But I will say, and I've been at Veeam for 10 plus years, backup is still quite boring. But it's much better than writing and managing a load of scripts. So if we think about that, I'll just build this out. So we can take advantage a lot of the time, either natively or using an orchestrator to do this. We can take advantage of volume snapshots. One of the key areas of a CSI driver generally is volume snapshots and volume snapshot classes. And that's just the workflow that it goes through. It takes that persistent volume claim, it snapshots that, and gives us a copy of that data from that point in time. Now, this is just like pulling the power plug on that MongoDB physical server. Will it come up? Maybe, hopefully. Fingers crossed it will. And this is why scripts and snapshots aren't really enough. Like if something happens to our cluster, if we want to move that, snapshots aren't going to get us out of that hole. You could script it, and maybe if you only have Pacman, maybe I could script it. Maybe I could use something to export that out into S3. Maybe I could use MongoDB, a logical dump file. But what does it really look like from a DR perspective? And to be honest, I want to hit the easy button on how we would protect that, especially if I've got multiple applications, different applications. Maybe I've got Postgres, maybe I've got Elastic, maybe I've got endless amounts of data services running in my cluster. So I would rather use something like Veeam Kasten. I'm not going to pitch this at all, but ultimately Kasten is a Helm chart deployment within your cluster. It's on a per node basis, worker node basis, and it allows us to take a consistent copy of that data service. So we're going to speak to Mongo, and we're going to say, I need to take a copy of that. Can we pause and make this consistent? Can we QS the workload? And ultimately, what happens is Kasten looks at that, dynamically discovers the application through the Kubernetes API. We become part of that Kubernetes API through aggregated APIs and CRDs. We then say, right, okay, we'll take a copy of not just that persistent volume claim, but the whole application. And then we can offload that as a snapshot. We can use something called a canister blueprint. Canister is a CNCF project. I'll touch on that in a second. And that's going to allow us to lock and flush and do that QSing that I mentioned of the application, if there is an application that needs that. And then we're going to leverage snapshots, but then we're also going to leverage the ability to export that out to an S3 location, like off cluster. Snapshots are great until bad things happen to that whole platform. Then snapshots are gone. If I'd have deleted the namespace, the snapshots also disappear. Canister, as I mentioned, so this is the fundamental part of that application consistency. This is what we use to, and we donated it to the CNCF a couple of years ago, and this gives us a framework to be able to provide the ability to talk to that application and say, I want a backup of this, and that might be to an operator to instruct lifecycle management tasks within that. Okay, so mistakes were made. We have Pacman, but maybe my wife played it and she added some bad data to it. My son only likes his high scores to be logged into our database. So Kasten's deployed within the cluster, becomes part of the Kubernetes API. Loads of services within that. Yeah, I don't know why I showed that. What time are we on? Oh, still in the workshop. Cool. So if I go and look at Kasten, so everything can be done through the API as well. So we could do CLI, we can create that, but there is an ops-focused dashboard as well. You see that it's dynamically discovered our application, and we can say create a policy. You could also say do an export or export of that, export and snapshot. We create a policy. When do we want to back this up? When do we want to trigger snapshots? Probably reduce that down. We don't want that many snapshots consuming our little VMs. When do you want to enable that export to go out to S3 or Azure Blob or whatever location? And then the canister was the last option. How do we want to inject that blueprint into our backup process? Submit that, say to run that job just to show you what this looks like, rather than waiting for the schedule. And this is basically orchestrating what we could do through scripts, like all good software is. We're just taking away that complexity and simplifying that with a scheduler and a data mover to be able to take that copy of that data. If we go and take a look at what's happening here, we're ultimately running that snapshot of our mission critical application. In fact, I think I'm too slow because everything's finished here already. Good work, me. Ultimately, so we're capturing everything in there, right? The whole spec of that application. So not just the PVC, but we're also capturing any other configuration parts of that, the pod, the deployment, the networking, everything that goes in that. So I've got a backup of our good data right now. So this is the wife. She can't play Pac-Man. Like it's dreadful. And we're going to simulate. This is bad data. Equally, I could have got like MongoDB Compass, and I could have got into the data. I could have encrypted it. We didn't really have time based on creating a demo at 3 o'clock yesterday, and they needed my slides. Okay, so we've realized there's a problem. We've got a snapshot of our environment or our application. So I want to get things back as fast as possible so my son can play Pac-Man and he's got his high scores back. An important part here is that, so yes, that's great, I can bring this back. Equally, I can transform what this looks like. And transform could be, I want to change what the storage class. Maybe I want to go from gold to silver or silver to gold. I can transform what that restore looks like here if I've got those provided options of different storage classes. Equally, I can import these backups into another cluster. Maybe I started Talos on-prem and I want to now use Talos in the cloud or vice versa, and I've got a different storage class because if in the public cloud, if I'm using Talos, I'm probably going to take advantage of the AWS native storage, and I'm going to use that versus the Rook Ceph overhead that I have on-prem. And I can transform what that. Equally, I can transform any of that application. If that could be how many replicas I want, it could be the networking, it could be anything we can transform. And that's where, from a disaster recovery point of view, I now know, especially if it's in S3, I can't do that with a snapshot, but if it's in S3, I can now restore my Pac-Man important data application into another cluster somewhere else. Hopefully you saw the restore process is happening and things should be back up and running any second now. The green lights there give away a good indication of the restore was successful. My typing is so slow. Okay, yeah. Now let's get back into it and just show a simple demo of recovering from that bad data being written, a mistake was made, and we just need to confirm that bad data is no longer there, and we just have those 2 high scores that we had previously, like bad data there. Refresh, got a high score, and we're back down to 2. And okay, it's just one application and one data type, but imagine that now times 10, times 20, times 30 of different applications, different data services, Postgres here, MongoDB, blah, 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 and having to manually write and maintain scripts around that. That's the end. I really wanted it to talk about like the disks. That's where we start with storage, regardless of where they are, whether it's shared storage or not. The data that we see, that we're seeing from a trend point of view in Kubernetes, but then also the use case of why do you need to consider backup, and where does that backup land as well? Is it on the platform team, the security team? That's going to be different across this room as to who has that responsibility. But yeah, with that, thank you very much. I'll be around for questions all day, but yeah, hopefully that was useful. Thank you.